Okay, once again we have with the method of shells, we have with the functions y is equal to x cubed, y is equal to 0, and we have the barrier function at x is equal to 3. Okay, and so just as a quick illustration, okay, we have x equal to 3, vertical boundary, and then we have the cubic function y is equal to x to the third, and we have essentially the x-axis with y is equal to 0, and we have a triangular formation, and looking at the volume generated about the y-axis and utilizing the shells, okay, it turns out that the height we will be using is going to be, again, the distance from y is equal to 0 to y is equal to x cubed, namely x cubed. So we have, in looking at the volume generated about the y-axis, again, we are integrating over the variable x. So we have for via y, okay, we're going from x is equal to 0 to x is equal to 3, and we have 2 times pi times x, okay, and it's going to be a positive x since we are over in the first quadrant, and we have times the height again, x cubed dx, and so we're taking the product, okay, we had that via y is equal to the integral as we go from 0 to 3 of 2 times pi times x to the fourth dx, and the rest, okay, is going to be using the power rule of integration and integrating numerically. We're going to have in the setup that for v of y, okay, we have 2 pi times x to the fifth over 5 as x goes from 0 to 3, and at the lower limit 0, okay, the term is rendered negligible once again, but at the upper limit 3, we were able to determine the volume of the solid generated about the y-axis, whereupon we had the exact value to come out to 486 fifths pi.